Welcome to Ask and Learn.
Okay, well, in this problem we have an air standard cycle with four processes. And the first process from 1 to 2 is a process with constant volume. So it's a constant volume heat addition. Now the process from 2 to 3 is a process with constant pressure. The 3, 4 is isentropic, and the 4, 1 finally is constant pressure. Okay, well, we have to actually describe in part A what is the PV and TS diagram of this process. So let's begin with the PV here. Let's put the axis. This is going to be our TS diagram. Okay, so according to the problem, we just need to describe these four types of transformations. Okay, the transformation 1, 2, constant volume, is going to be a vertical line. So we have here our vertical line. The process 2, 3, also a line, but a horizontal line because it's constant pressure. Let's put in here, I forgot to put here the PV and the TS label. Let's see. Isentropic, 3-4 isentropic. So isentropic is a hyperbolic transformation. And finally, 4-1. 4-1 is also a horizontal line. So that's the four transformations that we have. This one is an isentropic, which means that does not exchange heat with the surroundings. Let's enumerate here. We have 1, 2, 3, and 4. As we know, the heat enters in here, enters in here, and leaves in the final one. Now let's look to the TS diagram. Well, we know that isentropic transformations are described by vertical lines in a TS diagram. So this is going to be the 3, 4. Okay, so here we have 3 and 4. This is the isentropic curve on the TS diagram. So the 3, 2 is going to be this one, and actually 2, 3, sorry, and the 1, 2 is going to be this one, and the final one is this. So here we have 2 and 1, and again the heat enters here, and leaves here. Okay, so that's the part A. Describe the PV and TS diagram. Now let's see part B. What we want to find in part B. Part B, we want to find the heat input. So the heat input Qi is, if we look in the diagram, is going to be the heat from 1, 2 plus the heat from 2, 3. Okay, and the only thing we actually have to calculate is this one, because heat from 1, 2 we already have. Therefore, let's move on. Okay, what we know. First of all, we know that Q12 is equal 300 BTU LBM. Nice. Now who is uh, Q23? Since this is a constant pressure, this is the change in the enthalpy between 3 and 2, correct? And we have to calculate this, we must look in the table A17, because in this table A17 we have all the information that we want. So let's begin looking to point 1. In point 1 we have a temperature 1 which is 540 R. Okay, and this temperature of 540 R gives us precisely internal energy of 92.04 BTU LBM, and gives also enthalpy point 1 which is 129.06 BTU LBM. Okay, uh, what do we need actually? Well, if we have the internal energy of point 1, we can find the internal energy of point 2. So let's go to point 2. In point 2, we have a temperature 2 of 2116, sorry, R. And following this step here, what we know is that internal energy of point 2 is going to be equal to internal energy of point 1 plus the heat 1, 2. And that gives us precisely 392.04. Again, because we know that Q12 is 300. So we just need to add, to sum both the numerical solutions. Okay, and since we have the internal energy of point 2, from here we take, looking again in the table, that the enthalpy of point 2 is 537.1 BTU LBM. Finally, on point 3. On point 3, we have a temperature of 3200, 3200 R, and that gives us an enthalpy on point 3 of 8.49, sorry, not 8.49, I see, the enthalpy is going to be 849.48 BTU LBM. Therefore, now that we have both the enthalpy on point 3 and the enthalpy on point 2, we can finally calculate what is the heat to 3, and this heat is going to be just 312.38 BTU LBM, which gives us a final input heat which is 300 plus 312 of 612.38 BTU LBM. And finally, the last item of this problem, we have to calculate what is the efficiency of this cycle. So the efficiency is just 1 minus the output heat divided by the input heat. So Q out minus divided by Q in, So this is 1 minus 464.16 divided by 612.38, which gives us an efficiency of, let's see, 24.2%. Okay, so that's the final answer. Thanks for watching.